Hello, my name is Johnny Hammerland. I'm an automated test developer at MindBody Incorporated. In this demonstration, I'll be presenting a .NET Interpreted Selenium extension originally developed in Java by Francois Reynaud, also known as iOS-Driver. I'll also quickly skim through the basic structure of a Selenium wrapper framework made by my coworker called Bumblebee that we use to implement Selenium tasks along with its new accompanying extension, BumblebeeIOS, in which we've implemented the overhead of my IOSDriverJavaAdapter to provide a single interface for the end user result. The point of this demonstration is to present to the Selenium team a project idea for the upcoming Google Summer of Code. Rather than maintaining a messy and less reliable .NET interpreted Java library, we plan on actually creating the .NET bindings for iOS-Driver, whether or not it melds into the future release of Selenium or it remains an extension. So, by the way, if it appears laggy, I recorded this. I pre-recorded this video, so may not match up entirely with the audio, but here we go. So here's my existing project for a test session. As you can see, it's got some foreign classes existing, except the attributes, test, setup. These are all MBUnit attributes. It's a Galileo test framework. And you can see we're also using .NET Selenium. This is on the highest level, so this is where we're actually running our tests. And you can see we always start with a session, which is actually a class set up by Bumblebee. Go into that in 1 second. Yeah, there's a session object. This is the wrapper framework created by my coworker. You can see up in our using statement that it is under bumblebee.setup, where the core Bumblebee exists right here. Session. As you can see, it basically carries a driver along with some convenience methods. Always start off with the current block, which takes in an I block. We'll get into that in a second, but there we create our driver environment. This is where we basically begin each test, returning the current block that we're in. Yeah. This isn't the main focus, but spent a lot of time going over it. As you can see, we start at the home screen, which is a class that I implemented separately. I'll go over that in a little bit. In the setup, because the session itself has a protected constructor, basically implemented a test-based session, just so we can construct our own. The reason it's protected is typically you're going to add quite a bit of customization, but yeah, see, it's protected on the Bumblebee level, but probably going to make that public in the future. It takes in a iWebDriver or iDriver environment. A remote iOS environment is part of BumblebeeIOS, which is the Bumblebee extension that we created to conform with this new adapter. There's BumblebeeIOS. And basically, it takes in what most iDriver environments are created with, but the only difference is that we're taking in the bundle name right here. And this is so we can create a new Java driver, which is, as you'll see, it's one of my first adapter classes, probably the most. It's basically the bridge between our interpreted Java library and .NET. So you can see iOS capabilities. That's also a extended. You can see all the namespaces are a little bit odd. I fixed the namespaces after this recording, but it's not much of an issue at the moment. So here's our IOS-Driver Adapter. This is where we basically do all the IKVM work and interpret Java Selenium along with Francois Reynaud's Java driver, iOS driver, and implement .NET bindings. So as you can see, Java driver is in itself an extends remote WebDriver, Java remote WebDriver, but it also implements many of the C# interfaces. Our constructors take in the base constructor takes in capabilities objects, but our BumblebeeIOS constructor, well, the one that BumblebeeIOS uses, simply sends an iOS capabilities object, which is also defined within this interpreted library. It's right here. As you can see, it extends Francois' iOS capabilities object, and right here I was going to navigate to its definition, but instead I accidentally opened up an object browser, so it'll take a couple extra seconds. Yeah. So even though I accidentally opened this up, you can see that how messy it is importing all these interpreted Java libraries. This is why we plan on recreating the bindings to be C# native for Google Summer of Code. You can here, if we actually navigate the definition, iOS capabilities is a desired capabilities object which implements the capabilities interface. So therefore, iOS capabilities implements capabilities and IA capabilities. So it is a wrapper and an adapter. It's not well implemented. It's currently only built for its specific task, which at the moment is to build is to basically return a basic capabilities object to construct the driver, using the basic implementation of sending in or passing in the bundle name or the bundle name and the bundle version of the iOS app. And you can see the convenience of Java and C# strings being the same, essentially. And now I'm getting into specifics. Here's, for example, where I use this is an WebDriver interface or method that is implemented by using this by adapter that out of all the adapters / wrappers is sort of the most janky, just because it the by object by itself doesn't expose any properties. So basically what it does, it takes in a .NET by object and returns a Java by object based on its toString, which is sort of a hack, but it was the go-to method. There was no reason to use reflection. So and basically then that returns a web element, and then we construct a iWeb element by sending in that web element to this remote web element wrapper extension or wrapper class, which in itself is a remote web element and an iWeb element. So it's a lot like the Java driver, but it's a lot more of a wrapper than it is an adapter, as it basically all the methods they basically see the inner element as our web element. Basically, we're going to be calling the inner elements methods. see, I have wrappers all over the place. We have coordinates wrapper, alert wrapper. Really, a lot of them are only 1 or 2 levels deep. Cookie jar wrapper. There's our coordinates wrapper. C# coordinates wrapper for other way around. Most of them go both ways, but a couple of them needed a bit of maneuvering. Down, you can see that our Java driver also implements iTakeScreenshot as well as TakeScreenshot, which since this recording I've also implemented a few other interfaces such as the iJavaScript executor or something like that. I can't remember the exact name, which functions as well. Here, basically, to construct a screenshot, it's relatively simple. We call the getScreenshot method using the Java getScreenshot method, and returns a base64 string and construct a new .NET screenshot method, screenshot object based on that base64 string. And here we go. This is Bumblebee. Basically touching real quick on the I block, which is it's an I element, but it's more or less a hierarchy interface. Computer just went down. Hold on. My bad. Okay. So the iOS block it implements iBlock. So does traditional block. Basically, we navigate our page objects using this iBlock interface, and the iOS block allows us to have specific implementation if needed within BumblebeeIOS for iOS for view objects compared to web page objects. And here we have our Bumblebee elements. Basically, these iClickables are an example of iElements that the click is, if it's a clickable, that's basically going to be our only specific method. But here you can see that it returns the block that you're currently in. So, for example, this block returns the home string. From there, we have the sign up button, which has generic parameter of home screen as well. So we remain in the home screen. From there, we go to sign up screen. Once we click the sign up button. Or the login screen from the sign up page. Or I'm sorry, the sign up button goes to our sign up screen. From there, we're in our sign up page. Have the email, first name, last name fields in the sign up screen. You can see we have screenshot, save to local disk. Right here, I'll delete the old one. If I can navigate to it right here. Just to prove that it's gone for good. Delete our old screenshot. Okay. Now we gotta set up our grid node. So here we're using Francois' iOS-Driver to set up our grid node. Traditionally using an app called Project Gator. Here we go, grid node started. And now I just got to navigate back to our test. Here we are. Okay, here we go. We're setting up that session with Project Gator as the app bundle name, and we'll run that test. Okay, should go back to our Mac Mini. Wait for it to load. Here it goes. And the sign-up screen takes a good 25 seconds to load. It's just because it's very early in development. Nothing to do with UI automation or anything like that. Just a slow app at the moment. Okay, here we are at the sign-up screen. Should go email, first name, last name, password, confirm password. Click done, hit sign up. Hit skip. Wait about 2 seconds, take a screenshot, and exit. We can see that our test passed. And we can see our new screenshot. The last modified date is the same time as the current time on our computer. And there's our screenshot. And that's my presentation. Thank you for watching, and I hope that you guys strongly consider our idea for Google Summer of Code. In any case, we're going to be working on this project, so it would be great to have as much support as we can possibly get. Thank you very much.